Sathyabama Institute of Science and Technology.
Hello students, I am going to take about introduction to blockchain technologies for the beginners. So this is the overview of this PPT. What is blockchain? Definition of blockchain, structure of a block, how blockchain works, core components of blockchain, characteristics of blockchain, features, comparison between the database, comparison between different networks, types, history, generation, and what are the kinds of application of blockchain. This slide shows what is blockchain. So blockchain is a chain of blocks, so which calls plus chain. So that means list of blocks. So blocks is a collection of transactions. Chain is the list of blocks linked with cryptography. So this is the diagrammatic representation of the blockchain. So this is the basic definition of blockchain. Blockchain represents a system of recording information in a way which makes difficult or impossible to change, hack or cheat the system. So here the digital ledger will makes as a transaction the duplicated and distributed across the entire network of your computer networks. So this data or blocks will be stored in a chronological order. So this is the pictorial representation of the blockchain. So this image will shows the genesis block and latest block. So this is the first block of the blockchain, so which shows always 4 zeros. So and each and every hash will be represented, that is the next hash value will be represented in the previous block. So like that it will be n number of blocks will be added. So this is the sample pictorial representation for this blockchain, and this is the representation of block. So here all transactions are grouped together into a block. So which means, so here it contains data, hash and then hash of previous block. So data, what data we are created, it is stored here, and hash, so what is the cryptographic hash which was generated by the blockchain, so that will be included here, and hash of a previous block. So previous blocks value, hash value is also mentioned in this block. And this is the overall structure of the blockchain. So each block must contain these 4 informations. So first one block size, second thing is block header, third one is transaction counter, and last one transactions. So this block size have the overall block size. So usually this block size will be 1 MB only. So and in the block header, so all the metadata related to your blockchain, it will be represented. And in the transaction counter, so what all the transactions is performed under the blockchain. So and transactions, so in each block, so what transaction is performed, these things will be mentioned in the transaction block. So this is the initial block about the genesis block. So here it is always represented as the 0, so which represents, this is the starting position of your blockchain. So in this chain, so the traversed backward process is given in the block, so it will end up at the genesis block, it proving that entire chain is legitimate and valid. So in this genesis block, which is statistically coded, and it should be public, and it is a permissionless blockchain may be created in the participants. And this is the block header. So in this block header, so here we are having so many information. So these are all the information. This is the diagrammatic representation for that. So in this version, previous block hash, Merkle root, timestamp, difficulty target and nonce. So these information is stored in the block header. So previous block hash will represent the lost block creation, and Merkle root, it is one of the hash tree representation of your transaction blocks, so which summarize all the block informations. And timestamp, so at what time the block which was created, so that will be included there. And then difficulty of the target, so what are all the targets we are going to achieve related to the block. And nonce means the number created at once, so this which will be created for the block hash. Then next, so this is the diagrammatic representation for the blockchain working system. So here we have some 6 steps. So in this diagram, so first the transaction is required. So who required the transaction, they will make a request. So based on the request, a block that represent the created, whether it will be based on the requested, the block will be created. So after that, the block will be sent to the blockchain network. So and then, so this node whether will be validated or not, so this validation will be performed by the miners. So after that, So this miner will choose the consensus algorithm, which is proof of work. So usually they are using the proof of work. So this consensus algorithm is evaluated by the miner. So after evaluation, so it will be a correct one. So it will added, this block will be added into the blockchain, and after completion of the transaction, this will shows in the blockchain network. So in this blockchain network, so these are the three combination technologies will be included. So first one, cryptographic hash keys, second thing is peer-to-peer network, and with the help of shared ledger, and last one, the transactions record in the network. So these three technologies will be combined. So these are all the main four core building of your blockchain. So first one, shared ledger, cryptography, consensus mechanism, and last one, business rules about the smart contracts. So shared ledger means, so it is a distributor and decentralized network. So this decentralized network will share all the ledger informations in the overall network. So cryptography, which ensures that authentication of the verifiable transaction, and consensus means, so this is one of the methodology to verify your transaction and authentication. And last one, smart contract, so it is related to the business applications. So you can able to embed your contracts into the systematic code with the help of systematic code. So here we can able to create the rules and regulation. So after that rules and regulation, the condition will be satisfied, then it will be automatically executed in the network environment. And this is the representation of the linking block. So how each and every block will be linked together. So here, so first block will be created, so hash value, so through the hash value each and every block will be connected each other. And this is the cryptographic hashing. So here usually that is secure hash algorithm which is used in the blockchain technique. So either they were using SHA or SHA-256. So this cryptographic hash function is a type of function which maps, and it is a arbitrary sized data, that means the fixed size data is generated by the hash. And these hash function which have one of the input, the same input should not create same output. And this is the cryptography representations in the blockchain. So here these are the three steps always we are done, that is initiation of and broadcasting of transaction, next validation of transaction, then chaining of blocks. So in the initiation of broadcasting process, we are using the digital signatures and then public key or private key usages, and in the validation we are using the proof of work consensus algorithms, and in the chaining of block we are using the hash functions. So in this case usually, so the that is elliptic curve cryptography algorithm is used to generate the public key and private keys. So hashing technique usually they are used SHA-256. And this is the representation of the Merkle tree. So this is like a bottom up approach Merkle root. So here we are, say for example, we are taking A and B and C and D. So these two hash will be generated. So after generation this will be added. After that, so HC plus HC, hash of C and hash of D. So after combination we will get the Merkle root. So that whole hash will be generated in the Merkle root. And this is the characteristics of the blockchain. So here we have categorized into two things. One is functional characteristics, another thing is emergent characteristics. So functional characteristics are decentralized network, distributed ledger, consensus, immutable, and then security. So under the emerging characteristics, so transparency, trust, tamper proof, auditability, and anonymity. So here decentralized network means, so it is like, so each and every node will be act as a peer network. It is a peer-to-peer communication. And distributed ledger means, so those are all available on the network, everyone can able to view the distributed ledgers, and it is open to everyone. So consensus means it is here it is a mathematical puzzle. So that mathematical puzzle which solves all the problems based on the problem, it is like a puzzle. And next, immutable. So once the data is created, so we can't able to change the modification in future. And security, so here it is each and every person, the decentralized system will make it as a secured one in the blockchain network. And emergent characteristics, so in the transparency, so the transparency will be, transparency means everyone, so those are all available on the registered network, so everyone can able to view the all transaction process. And trust, so it is a trusted one because there is no maximum, the malpractices will be very less when compared to other networks. So, and tamper proof. So, here the immutable character should avoid the tamper processing. And next, auditability. So, once if you are going to create any the transaction or any network related works, so you can able to backtrack the works. And then anonymity. So, here we are using the addresses. So, because of that, so we can't able to know who is the corresponding person in this. And next, this blockchain, how it is differ from the database. So, in the normal database, it is a centralized network. So, here we can able to create, read, update and delete operation. So, it is shortly represented as CRUD operation model. So, in this model, so here we have the server database and database clients. So, everyone can able to connected here, and in this normal database, the administrator only the responsible for person to manage the server. So, remaining people, so based on the privileges only they can able to use their options. And but in the blockchain environment, so each and every node will be connected peer to peer, so that all the data will be included in all the peer networks. So, here you can able to read the data and we can able to include the data, we can able to modify and delete the data. So, that is the major difference between the databases, existing databases and then current blockchain systems. And this is the different network environments. So, usually nowadays we are using mostly centralized networks, and again distributed network we are using. So, this decentralized network is used in the blockchain network. So, in the centralized system, so we have so many number of users and one server. So, but in the distributed system, the more than 2 or 3 servers and more number of users, they will be connected to any one of the server. And but in the decentralized system, each and every node will be act as the server. So, this is called as the peer-to-peer network. So, and this is the key components and differences between the each and every networks. So, here these are all the key points to distinguish each and every networks, that is network, hardware resources and data, control, single point failure and fault tolerance. So, security wise, so for these are all the some of the differences which is displayed here. And what are the disadvantages of the centralized system? So, it is a highly dependent of the network connectivity, and here no graceful degradation of the system. That means the if any one of the system may get failure, the total network will be affected. And here the maintenance of the server is also somewhat difficult, and low amount transactions locally and huge waiting time for the transactions, and validation of charge will be very high when compared to other networks. And advantages of the decentralized systems. So, here we have 3 advantages. One is minimal problem of performance, and then high availability and more autonomy, and also the control over the resources. And these are all the features of the blockchain. So, one is immutability, decentralization, enhanced security and then distributed ledger. So, immutability means, so here we can't able to modify any data once you updated, and decentralization which is a shared among the nodes in the network, and enhanced security. So, here we are using the encryption and decryption methodology, so that our data will be securely transferred. And next, distributed ledger. So, in the distributed ledger, so multiple number of data we can able to store and we can able to distributed in the network. And these are all the advantages of the blockchain. So, that is transparency is very much, and security is also more, and then efficiency is high, then speed is also high and reduced cost. So, in this reduced cost, without the third party we can able to success all the works in the blockchain. So, remaining part we will be perform in the part 2. Thank you.